I'm going to kick it off answering the question, how does science work? And I like to say even better, like, how do we science? Like, how does that sciencing happen? And I'm going to try my experiment again. I don't know if y'all remember the good old red balloon and the green balloon. And folks could even type in the chat, like, oh goodness, what do you think's going to happen this time? And I'll say this. So, what I learned last time, I had the wrong color green balloon. And that's why my experiment didn't work. And in science, you know, it's a series of trying things out to see if we can get it to work. And this time, I'm confident that we can get this to work. And I'm blowing up my red balloon inside my green balloon. And the key is, as a scientist, what I'm really looking for is I want that green laser to go through my red balloon, and I want my red balloon just to absorb it. And before, oh no. And that's pretty hilarious. The red balloon deflated inside there. And this is how science works sometimes. It doesn't work how you want it to, and that's okay. So what I'm going to do, just to save time, mine's not working, but I know Gabby's experiment is ready to go, and she's ready to answer her question, and we'll come back to mine at the very end. All right, Gabby, take it away.
Hi everyone, I'm Gabby. And so the question that I'll be answering is, why does oranges have peel? So starting off, a peel is also known as the skin. And this skin is a protective layer for a fruit or a vegetable, and it can also be peeled off. So this peel protects the fruit or vegetable from any damages from the environment. For example, like viruses or bacteria. So, because it could be damaged if a virus goes inside a fruit. And also, a peel creates this toxin or this unpleasant flavor so birds or insects won't eat them. But those toxins are toxins to us humans. So, and there's also different types of peels. So, for example, in orange, if I touch the peel, this peel feels rough and thick. And indeed, it is thick. And this type of peel, we tend to peel it off because it is difficult for us to digest this. And if I bite this, it will have an unpleasant taste. And I'm not going to bite it because I already tried it and I did not like it. And this different type of peel. And can y'all guess what type of peel this fruit is? So this is a grapefruit, a grape. It's from a grape. And if you see, it's very thin compared to the orange one. So this type of peel, we don't peel it off. We tend to not peel it off. And it's the same as an apple. So this is also a thin, it's very thin, and we tend to not peel it off. But sometimes we do. For example, Heather was mentioning to me that when she does apple pies, she does peel it off because this type of peel can be a little bit bitter. But for example, another ones like an avocado, this type of peel, we do peel it off just because it's thick. And it's also like a mango. We do peel this off because it's the same as the orange. It has like a bitter taste, so it's unpleasant taste to eat it. So, yeah, that's why. So, in general, the peels are there for protection from any damage from the environment. And if you think about it, we also have a protective layer, which is the skin. The skin help us to protect it from anything. So, it help us protect our muscle and our veins. And I challenge y'all to think about what other things have this protective layer that can help it protect the inside of it.
I
And then,
like, I know I like potato skins. Potato skins are pretty delicious.
yes. So it just depends what type of peel we're talking about. Sometimes we can eat it and sometimes we just don't eat it.
I like I hear one of the folks is saying they use orange peel in their baking.
Oh, yeah. So it's a lot of different ways to use the peel too. And it's also sometimes good for us. It has a lot of nutrition.
And one thing about the orange peel is you probably only use the outer layer of the orange peel because it's really that inner part where all that bitter with those toxins that Gabby was talking about come in.
Yes. So another question that I got was, why are leaves green? And so there's a secret ingredient. And that secret ingredient is only found in green leaves. So to get a closer look up to this ingredient, we will need some leaves. Let me put my camera down. Some leaves. It doesn't matter what type of leaves. So for this demonstration, I'm going to use from my apple tree, a regular tree, and spinach. And then you will need a cup and alcohol and some paper towel, sorry. Then, so the first step we're going to do is crush the leaves, crush it. You can also use a blender, but it doesn't really matter. So you just crush it and you put it in the cup. And then you pour some alcohol, not too much, not too little. Just
Is that something parents should maybe help out with, the alcohol part of things?
yes, they should. And then after this, we will tear the paper towel. You want to tear it a strip. It doesn't have to be perfect. And then you will put it inside the cup and wait. So you will wait around 1 hour, 2 hours, or you could leave it overnight. So that's what I did. I left it overnight, and this is my results. This is what I got from my regular tree leaf. This is what I got from my apple leaf.
Whoa, I see green and like kind of an orangey brown at the bottom.
Yes. And then this is my spinach. So this shows that leaves not only have green, but they also have different colors. So remember the secret ingredient that I was saying earlier? Well, the secret ingredient is called chlorophyll. And this helps the leaves to be green. And it's so strong, it's so dominant that when chlorophyll is present, it doesn't let the other colors show. So for example, for my regular leaf that I got, you see that chlorophyll is present because it's green. You could see green. But when the chlorophyll dies and it goes away, the green also goes away. So it makes the other colors show off, pop off, just show off. So, and like Heather was saying before, for my apple leaf, this one looks a little bit different because it shows like a brownish right here. And the reason why is because right now my apple tree, the leaves from my apple tree, they're already changing color. So that means that the chlorophyll is already dying. So that's why the other colors are showing off more than the green, because the chlorophyll is already dying. So when the chlorophyll is present, that means that it's green and it doesn't let the other colors show. But when it's dying, the green goes away and it lets the other colors from that leaf to show.
Oh my gosh, Gabby, I love this. This is so cool. So you're showing us not only answering questions, but you're also showing us how to science, like how we could do this in our own backyard, literally.
Yes, literally, I got my leaves from my apple tree. You could see it. It's already changing colors. And then my other tree over there that's very green. It has the chlorophyll there and it's not going to change until that one dies.
Could we do this with like dandelions that are in our yard?
Yes, we could. We could try it with anything. That's what science is about, trying and seeing what you get in your results.
This is awesome. I love it. Thank you so much, Gabby. We can give you a round of applause. Yay!
Hey, Gabby, real quick before you finish, I was wondering, does it matter what kind of alcohol you use with adult supervision? Is this a specific type of alcohol?
No, I don't know.
I think we used isopropyl alcohol, also known as rubbing alcohol for this.
Rubbing alcohol, yes.
Yes. And
Yes,
so you want to use isopropyl or rubbing alcohol to do this experiment.
yes.
That's a good point. And I see somebody has a question. If you want to type your question in the chat to one of us so we can answer your question, I'd love that. And next, to answer the next set of questions is Nina. Nina.
Hi. Hi, everybody. So the first question I'm going to answer is, why is the sky blue? This is a really awesome question. And I have a little experiment for you, one that you can also try at home to do science yourself. So right here, I have a 2-liter bottle, and this is just filled with milk and water. So it's mostly water with a few drops of milk. And what this is supposed to do is simulate our atmosphere. So in our experiment, this bottle of water and milk is kind of like our atmosphere. So I will show you why the sky, right now you can kind of see this just looks white, but our sky looks blue, right? So why does it look blue? I'm about to show you. So I'm just going to be using the light on from my phone, the flashlight. And most of you probably have access to something like this. So this is a really easy experiment for you to try for yourself. I'm going to just turn off the light so we can see a little bit better. All right, so when I place the light on this water bottle, you can see that the white actually looks kind of blue. And if I turn the light to the other side, that really looks orange. It actually looks like the sun, right?
Whoa, that like the sun last summer during the fires.
Yeah, so that's really similar to this. So the reason our sky actually looks blue is because blue is the color that scatters it the most. So that's the color we see with our eyes. But you'll see a different color as the angle changes. So when the sun starts to set, you see in the sky like orange and pinks. And that's because the sun is at a different angle. So we're able to see other colors. And it turns out that we see blue only because that's the color that our cones pick up on in our eyes. But it actually turns out that the sky is really purple. It's an ultraviolet, but our eyes cannot see ultraviolet. So we're only able to see the next best that we can pick up, which is blue. So that's why our sky looks blue to us. All right. So the other question that I'm going to be answering is, how are tsunamis made? Which is a great question. This is, I'm going to put on some gloves because it gets a little messy. This is a question about waves. So when there's an earthquake, what happens is underneath the water, the plate tectonics move and one shifts, and then that creates a wave that comes out from the plates, right? And that'll affect the water. So I have a little beach scene. So we have, this is the ocean and this is on land. We have a few people having a beach day up here. And this is what is going to be our plates underneath the ocean. So if I just move this barely, you'll see how normal waves are made, right? This is what a tide looks like on the shore. But if I pick this up and put it underneath and pull it up really quickly like a plate, it washes up all over the shore. And it almost takes out all of our little characters, right? So this is how a tsunami works. We just get a big rush, a big, huge wave that'll push all the way to shore and just wipe everything out. So there's things that we can do. I have little popsicle sticks, and we call these bio barriers. So most of the time they'll plant really big trees along the coastline where they're more likely to get earthquakes. And I'll just place some of these popsicle sticks here to represent some trees or fences. And what do we think will happen on the side that has popsicle sticks? All right, so let's make another tsunami. I don't know if you can see that very well, but the little guy in the car over here didn't get near as wet as the duck and the other fella over there. So that's kind of how we protect ourselves from tsunamis.
Wow, I love this. This is so cool. And again, like, you're sciencing, and they could try this at home. You know what would be awesome? Summer's coming up. I'm thinking pool party, and we make tsunamis in the kiddie pool outside.
Yep, the key is to make a tsunami, you just basically need a big force to create an initial big wave.
I love this. Thank you, Nina. Round of applause for Nina. Yay! Sweet. So next up on our list is Reagan, and Reagan's going to answer some more exciting and fun questions.
Hi, everyone. Yeah, so I got some really awesome questions. And one of my first question is, how does magma travel up the volcano and spit out with so much power? So the reason behind this is pressure. You know, we know that magma boils up under the surface, and when it boils up, it creates a lot of pressure. And I have a really cool demonstration to show you about pressure. So this is what we call a stop rocket. This is a 2-liter bottle, a tube, and a pipe, a PVC pipe. It's plastic. And I have my little rocket here, which I just made out of paper. So I put my rocket on the end. And what I'm going to do is I'm going to step on the bottle. So the bottle is filled with air, which means it's filled with pressure. And what do you think is going to happen when I step on the bottle? Go ahead and think about it and send me a chat.
I have somebody saying it's going to fly.
Let's find out. So you probably couldn't see that, but it actually hit the ceiling and came down in front of my computer. So that shows how magma shoots out of volcanoes with a lot of force. My next question is, what is the science of balance? How do we balance, and why do we need balance? So the answer to this, how do we balance, is our muscles push and pull on our body to help create opposite forces. So I don't know if you've ever seen a seesaw, but when one person pushes down, the other person goes up. Well, if they both pushed with the same amount of force, they would stay balanced. And I'm going to show you a really cool trick to demonstrate how we balance. And what I'm going to do here is I'm going to tip over, but I'm going to keep my center of gravity, which is in the middle of my body, over my arms and legs to hold me up. Now, this is a special trick I learned when I was in dance called a baby freeze.
Whoa, that's awesome.
So yeah, that's my demonstration for balance. And we need balance to keep us from falling over. My next question is, why do our brains and bodies need practice to be good at certain things? And the answer to this is the way our brains work is it's basically like a big maze. And when we learn a new skill, our brain makes a new pathway. And every time you practice that thing, the pathway gets stronger and stronger. So we actually have to practice pretty much everything we do. So you probably don't remember learning how to walk because when you did, you were a baby, but you had to practice that a lot too before you got good at it. So it makes sense that every time you learn a new skill, you have to practice it. You're strengthening those pathways in your brain.
Oh, I love this. This is so cool. Maybe we should continue to practice science. I love that. Thank you, Reagan. Cool. Round of applause for Reagan. Yay! Excellent. So last up is Connor. So Connor has some more questions to answer from you all. Take it away, Connor.
Hi, yeah. So the first question that I'm going to answer is, how does the internet work? This is actually a multi-part question that I'm going to answer more later. But right now I'm just going to talk about just sort of how like Wi-Fi works in the internet in general. So when you connect to your Wi-Fi, you're basically sending out a lot of light, like using your phone or your computer or whatever you're using. It has a little antenna in it. So like, oh, I put it away, dang. Radios with the big antennas, your phone just has a small one, or your laptop just has a small one built in, so that it can send out light rays, and then the device, your router or access point, however it's set up, can receive those. And I set up a cool demonstration to sort of show how that works. Sort of. Let's see if I can. So, what you can see here, you can't see me, but you can see up at the top on the ceiling, there's the access point. That's the Wi-Fi device that my laptop's connected to and is sending my voice and this little bit of video out. And then down at the bottom, I have my phone hooked up to a device we made that turns the music that it's playing into a little laser. I'm blocking it. Right here on this, oh, gotta switch back, there we go. On this whiteboard, there's a little laser here. I can bring my hand here. That's actually playing music from my phone right now.
It's playing music from your phone, but I can't hear it.
The speaker's gone. It's actually just disappeared. What?
Ooh.
Sounds like we had a science mishap.
I am having a science mishap. Oh,
I
where did
understand
it go?
that, Connor. I have that often. You know,
Everything else
while
is
you
ready.
look for your speaker, Connor, should I give the balloon a second try?
Yeah, you should give your balloon a second try.
I like that. And if I had some people direct message me saying we need to do the balloon, which we're ready. So I've got my laser again. This is literally a lightsaber. So for all those May the 4th be with you fans, this is literally a lightsaber. See what that looks like. Okay, and we'll see how quickly this happens this time. Hopefully. Will it go? Is the question.
Is science on our side?
Come on, science! Science, work! I see it kind of working.
Maybe it's like Tinkerbell, you have to believe.
Oh, do people believe? Come on! Clap if you believe! Maybe that'll make it happen! Yes, yes, come on, science!
Maybe.
Oh, man, I tell you, science is not on my side today. Oh, And
And
a
that,
lot of times science is, they call it a series of failures with one win. It's not that pessimistic, but science can be a lot of practicing before you get it just right and get exactly what you need. And I'm gonna try a different part of the balloon and see if that'll work. Man, and just, I tell you, I believe, and I have a lot of people telling me that they believe, and I think that is awesome. I believe it's gonna work. Maybe, come on. And I might just let it sit and maybe we can tune back into Connor and see if Connor has better luck than I am.
I found it. I don't know why. It was all the way in the back. So I left it there. Don't know when. But what I have here, this is a little solar cell. So like a solar panel hooked up to a speaker. What I'm going to do is hold it up to the laser. You can actually hear the music that my phone's playing from all the way across the room.
What happens if you put your hand in front of the laser?
If I block the laser.
Wow. And this is how technology works. This is how I talk to people on the internet, like have a Zoom session.
Yeah, that's the exact same thing that's happening. Like right now, if you're on a wireless device, a phone or a laptop, your computer, whatever it is sending light to your Wi-Fi point, essentially, and it's communicating that way, back and forth, using very, like, bigger waves of light than this red laser. But that also shows you why you get worse Wi-Fi in other rooms. So like if you have your router in the basement and you're upstairs, you get slower speeds because it's harder for the light to travel through the floor or through the walls and reach your device.
Wow, this is so cool. And Connor, I think we might have 1 minute left if you wanted to show us something really quick, or would you rather do a video later for us?
I can show us something really quick to answer a question that I got in the chat. So I got the question, why does the laser not see normally? So the like Wi-Fi light. So there's different colors of light. We know that like red light has basically a longer wave than purple light, which is a really fast short wave. And so this laser is it's bigger than the green laser that Heather has. And then actually the Wi-Fi laser's light is a very, very big wavelength compared to like the light that we see. So like you can't see the infrared like I have here, the sort of like double camera setup. If it will, there we go. So this is seeing like far infrared on the left side of the screen and then visible light on the right side of the screen. We can't see what the like grayscale camera is seeing. We can't see all that, but it's seeing like various things around us.
Wow. So it's this light we can't see, and maybe it's good we can't because there's so much of it all over.
Definitely. All of the like cell towers you see around, all of the satellites up in space sending signals down, radios, all of like the ultraviolet light that's smaller than visible light. There's a lot of light going on all around us. So if we were to see all of that, everything would be really bright.
Well,
and Connor, this light that you can't see for the Wi-Fi for the internet, are those radio waves, or those microwaves, or are those something else?
Those are Technically radio waves.
Okay,
They're
cool.
a bit bigger than microwaves, but also if you've ever noticed that like Bluetooth headphones or like if you're watching a video on your phone while you're cooking something in the microwave, it has to buffer. They're close enough that the microwave actually interrupts the Wi-Fi signal because that like length of light is close enough. Woo!
And there we go. I think that's a great place to end. Everybody give a round of applause to Connor. Yay! This is an awesome team of people. We do lots of science, but we need you to keep doing science, keep asking questions. And I think it's great that you ask questions. And with parental supervision, I think you can answer all the questions that you ask and check with us next week. And we should have questions for you. Thank you to the whole Little Shop of Physics team. Thank you to Adam who hosted us and everybody. Thank you to all the teachers. And I don't know if any of the teachers would like to give a closing piece to things before we sign off.
I will do that. Heather, it's Mrs. Ariano, everybody. Thank you for your attention today. And thank you to those students who sent in questions. Raise your hand if you learned something new today. Me? I did.
I did.
About the sky and the color of the sky. What a crazy thing to know that there's so many other colors, but mostly what we see is blue. And I know a little bit about that because I'm a birder and I know that there is blue made by birds. That's the color we see based on the light that reflects off their feathers. What? Thank you, Little Shop. We have so loved having you with us this spring. You've really made us just think in new ways and we appreciate you. So thank you. Thanks to everybody who came today.
Yay, thank you. Bye, everybody.
Bye, everyone.
Bye.